What's going on, my MathCounts friends? I've got warm up 8 from the 2026 problem set. Let's do it. Brennan has some pennies, nickels, and dimes. He can pay any amount of money from 1 cent to 25 cents in exact change. Good for him. What is the least total number of coins that he could have? Okay, so he can pay out any value from 1 to 25. So I know he definitely has at least 4 pennies. Okay, so if you've got 4 pennies, that can cover 1 cent, 2 cent, 3 cent, 4 cent, up to there. Now, if we go up to 5 cents, we could add another penny if we want to, but I'm not going to, and here's why. I'm going to do 1 nickel. How do you spell nickel? Spelling's hard. So I'm going to use 1 nickel because now we can do 5 cents. And then we can do 6, 7, 8, 9 using the pennies and the nickels. If I would have done 5 pennies, I would have been stuck at 5, and then I'd have to do more pennies to get to 6. So once we have cleared out the pennies, then we can move on to nickel. And now I can do 9. Now instead of doing a second nickel, I'm going to do a dime. And now I'm at 10. Then I can do 11, 12, 13, 14, 15 plus the dime, 16, 17, 18, 19. I now have everything I need for up to 19 cents. Instead of adding a penny to get to 20 cents, let's add a second dime. And now I can make 20 cents. I can use 21, 22, 23, 24, and then 25. I've got everything I need. I've got 4 coins here, 5, 6, 7, a total of 7 coins. Next one. Okay, so this one, for some reason the copy you can't really see very well. The shaded area, I believe, is this area right here. Okay, so that's my shaded area. Dartboard shown on the right consists of 2 circles. The radius of the outer circle is twice the radius of the inner circle. All right, so this inner circle has a radius of r, which means these are both r because the outer circle has double the radius. Okay. The shaded region represents 1/8 of the area of the dartboard. What is the measure of the unknown angle x? Express your answer in degrees. Okay, so what we have is a sector area here. So the whole thing we would call a sector. And generally when you do a sector, you would do the central angle x divided by 360. So that's the fraction of the circle because the circle has 360 degrees in it. And then you would just multiply it by the area, pi r squared. So that would be the area of the entire piece of pie right there. But we don't have a sector. We've got a partial sector right here. But wait, that's not too bad, because what we can do is we can take the entire sector's area and then subtract out this smaller sector right there. And what we would be left with is this shaded region. Okay, so the whole sector would be x over 360 times pi. The radius is 2r squared. Then we're going to subtract out the small section. So I just did the big section. Now I'm going to subtract out the small section. X over 360 times pi r squared. The only thing that we really need to change at this point is that this section here, 2r times 2r is 4r squared. So we've got pi over 360, 360, times 4r squared, pi, I kind of did it weird there, oh whatever, x over 360, and I'll just do it the same way. I don't know why I did it like that. We're just moving on. All right, so that shaded area is equal to what? It's equal to 1/8 of the entire area of the big circle, the whole dartboard. Well, the entire area is pi r squared, but r for the entire circle is 2r. All right, let's fix this one right here, because this should be 2r times 2r, that's 4r squared. All right, I'm going to simplify this quite a bit. Here's what I'm going to do. I notice that all three terms have pi in it. So let's get rid of the pi's first. I notice that all three of these terms have r squared in it. Let's take away the r squares. Okay, so I took away pi, I took away r squared. I basically divided by pi r squared, because this had pi r squared, this had pi r squared, this had pi r squared. Let's see what we're left with now. Over here, on this section here, I'm left with 4 times x over 360. That's 4x over 360. It's a different color. Over here, all I'm left with is x over 360. On the other side, I'm left with 4 times 1/8. 4 times 1/8 is 4/8 or 1/2. It's looking better. I can combine these. 4x minus x is 3x. So I've got 3x over 360 equals 1/2. I could reduce here. I'm just going to do cross products at this point. 3x times 2 is 6x. 360 times 1 is 360. Divide by 6 on both sides. X is 60. So that angle must be 60 degrees. It's kind of some fun math that they had us do. All right, so that's just kind of knowing formulas and then knowing that you can reduce these, and then it becomes a much simpler problem. 60 degrees is their answer. Okay. Next one, number 103. There are 60 arc minutes in a degree. Okay, so that's a ratio. 60 arc min over 1 degree. 60 arc seconds in a minute, arc minute. 60 arc seconds in 1 arc minute. A circle rotates completely once every 24 hours. Okay, how many arc seconds does the circle rotate every second? Okay, so if every 24 hours it rotates completely, that means that 24 hours is equal to 360 degrees. All right, these are all my ratios. And my final answer, I want in the following units. Arc seconds divided by seconds. That's how they want my answer. Arc seconds per second. So, here's what I got. All right, so the first thing that I notice, these are seconds. I need time in the denominator. So I'm going to take this first one and flip it so that I have 360 degrees. I'm doing this as a conversion problem over 24 hours. Now I need seconds in the denominator. So I'm going to do 1 hour is 60 minutes. My hours would cancel, and now I have degrees per minute. I want seconds on the bottom, so one more conversion. I'm going to do 1 minute is 60 seconds. So now minutes have reduced, and now I'm in degrees per second. Remember, I want arc seconds per second. My denominator is in the right units right now. So we need to get rid of degrees. So I'm going to do 60 arc minutes over 1 degree. The degrees have now canceled. My units are arc minutes per second. We're almost there. We need arc seconds per second. So the last one I'm going to use is this one. I've got 60 arc seconds per 1 arc minute. That's what this conversion says we can use. So that means arc minutes cancels with arc minutes. What are my final units? Arc seconds in the numerator, seconds in the denominator. That's what I wanted. I wanted arc seconds over seconds. So now I can just start reducing stuff to my heart's content. 60 cancels out this 60. 60 cancels out that 60. And now I just need to do 24 into 360. That goes in there evenly, I'm pretty sure. Let's just do by 12s first. 12 goes into this 2 times. 12 goes into this 30 times. And then 2 goes into 30 15 times. My final answer is 15, I believe. Did I do that right? Where's my answer? Yes, my answer is 15 arc seconds per second. Just a conversion problem. Number 104, how many non-congruent triangles with integer side lengths have a perimeter of at most 7? Okay, so we want a perimeter of at most 7. Let's keep track of our 3 sides. We'll call the 3 sides small, medium, and large. Now, you cannot just use any 3 sides to make a triangle. In order to make a triangle, the 2 smallest sides have to be, the sum of the 2 smallest sides has to be bigger than the 3rd side. Here's why. Let's say that I had a side length of 3, and then this side was 1, and this side was 1. These 2 sides couldn't touch each other because the 3 is too wide. So I cannot make a triangle from 1, 1, and 3 because these 2 sides could never touch each other. So the 2 small sides, we'll just call them A and B, have to be bigger than the larger side, we'll call C. All right, and we know that at most their sum, the perimeter, has to be at most greater than or equal to 7. Okay, let's start with the first one. The first one, I could do an equilateral triangle. 1 plus 1, and then 1. 1 plus 1 is bigger than 1. It's an equilateral triangle. The perimeter is 3. That works. Okay, there's my first triangle. An equilateral triangle where all the sides are 1. All right, let's try to make another one. Let's do the next one. 1 plus, let's change the medium side to 2. The larger side can't be 1 because that wouldn't be larger, but it can tie with the medium side. We'll call this 2. Here's my second triangle. 1 plus 2 is 3. 3 is bigger than 2, so that would work. So this is 1 plus 2 plus 2. That has a perimeter of 5. So yes, that's a second way we can do it because the perimeter is greater than or less than, less than or equal to 7. All right, let's try to make another one. Let's try 1 plus 3 is greater than 3. Yeah, 1, 3, 3. That should work because 1 plus 3 is 4. 4 is greater than 3. So it's another isosceles triangle here. And that adds up to 7. All right, we are tapped out on 1s. I can't go up to 1, 3, 4 because that's more than 7, and 1 plus 3 is not bigger than 4. So let's try 2s now. Let's try an equilateral triangle where they're all 2s. This does work. 2 plus 2 is 4. 4 is bigger than 2. and that adds up to 6. All right, let's jump it up a little bit. Let's do 2 plus 3, and let's make it isosceles and make this one 3. 2 plus 3 is 5. 5 is bigger than 3, and these all add up to, wait, this doesn't work. This adds up to too much for the perimeter. That adds up to 8. What did I miss? Oh, I missed another option. We could have done 2 plus 2 and 3. There we go. That makes 7. 2 plus 2 is bigger than 3, so that works. That was my last one. 2 plus 3, 2, 3, and 3 made 8, so that didn't work. So it looks like there's only 5 combinations we can do, 5 separate triangles that would work and satisfy this having a perimeter less than 7. So 5 triangles. I think that was the answer. It was. Good. All right, next one. A square has a perimeter that exceeds its area by a positive integer n. What is the sum of the distinct values of n? Okay, so we've got the perimeter exceeds the area. So this means the perimeter minus the area equals a positive integer n. All right, so perimeter for a square would be 4 times the side length. And then the area would be side squared, and that's going to be n. So there's not going to be a lot of these that are going to work. We can just try plugging in numbers to see what works. I think when I did this, I factored it first, which really wasn't necessary, but whatever. Let's just plug in numbers. Let's say s is 1. So if s is 1, we would have 4 minus 1. 4 times s, 4, s squared, 1. That would give us an n value of 3. So that works because 3 is a positive integer. Let's try an s value of 2. So if I do 2, 4 times 2 is 8. 2 squared is 4. 8 minus 4 ends up being 4. So there's another value of n. And let's try a side length of 3. We try a side length of 3. 4 times 3 is 12. 3 squared is 9. We get an integer value of 3 again. Let's try side length of 4. 4 times 4 is 16. 4 squared is 16. Uh-oh, 0. We need n to be a positive integer. This doesn't work. And 5 doesn't work because 4 times 5 is 20, and 5 squared is 25. I now get negative numbers at this point, and that's going to continue to happen. So these 3 are the only ones, but you have to read closely on the question. What is the sum of the possible distinct values of n? There are 3 of them that work. So 3 plus 4 plus 3, that comes out to a total of 10. Next one. What integer satisfies this? All right, so what I would do first is I would do cross products. X minus 1 times x minus 5 should equal x minus 4 times x minus 3. So if you're good at multiplying binomials, you can probably already see the answer to this. I'm going to walk through it a little bit slower. X times x, x squared. I'm just using the distributive property. X times negative 5, negative 5x. Negative 1 times x, negative x. Negative 1 times negative 5, positive 5. These two like terms give us x squared minus 6x and then plus 5. Other side of the equation. X times x, x squared. X times negative 3, negative 3x. Negative 4 times x, negative 4x. Negative 4 times negative 3 is positive 12. Combine these two like terms on this side, and we get x squared minus 7x plus 12. Oh, okay. So at this point, subtract x squared from both sides. Those go away. Let's add 7x to both sides. We end up with x plus 5 equals 12. I'll subtract 5 from both sides, and x is 7. So 7 is our answer. I think, let me double check my answers. Yep, there it is, 7. Next. Ooh. A frog is trying to hop from one shore to another using 18 lily pads arranged in a line across the pond. The frog can hop either 2 lily pads, which is a double hop, so they skip over 1, or 3 lily pads, a triple hop, which means they skip over 2. In other words, the frog cannot jump from shore to the first lily pad because they're either going to skip the first one or skip the first 2. Nor from the last lily pad to the shore. If the frog makes it across in the fewest hops possible, how many different ways can the frog hop from one shore to the other? Okay, so there's several things happening in here, but the first thing that you have to realize is how many total spaces this frog has to move. You might be tempted to think, oh, there's 18 lily pads. He has 18 spaces to move. Not so. Here's the first shore, and then we've got 18 lily pads here. So if I hop, that's 18 different places to hop to. But then you have the shore, you have one less hop, one more hop over here. So you've got a total of 18 hops for the lily pads, single hops. But then you still have to get onto the shore, so there's one more hop there. We've got 19 hop spaces. Okay, that's the first thing you have to realize in this one is that it's just not lily pads. You have to jump to the shore. So you've got these 18 hops or 18 pads that you can hop between, and then final hop gets you onto the shore. So that's the first thing you need to realize. Second thing you need to realize is we need to get the fewest number of hops possible. To get the fewest number of hops, I need to do as many triple hops as possible. So if I've got 19 hops, I need to do as many triple hops as possible. But here's our problem. If I do 6 triple hops, 6 triples, that gets me to 18 spaces, but I got 19 spaces, and I don't have single hops. I've got triples or doubles, so I can't do that one. So then, what if I did 5 triples? 5 triples would get me to 15 spaces. Okay, now this is going to work. I need 4 more spaces, so I'm going to do 2 of the double hops. That's going to get me across 14 spaces, and this is my 19 spaces. This is the fewest hops possible. We maximize them are our triple hops, which gives us 15 spaces, and then we used 2 extra of these ones. So I can use 5 of the triples, 5 trips, and 2 dubs. 2 double jumps. Okay, so at this point, I need to be able to find out how many combinations I can do from 5 triples and 2 doubles. Well, 5 are the same and 2 are the same. I've got a total of 7 jumps I'm going to do. There are 7 factorial ways to do those jumps, but 5 of them are triples, so 5 of them are all the same, so I have to divide out that, and 2 of them are doubles, so I have to divide out that. So our answer is going to be 7 factorial divided by 5 factorial, 2 factorial. So these cancel. I'm left with 7 times 6, and I divide by 2. So 7 times 3, 21 different ways to do the different hops. Next, Rachel uses a pumpkin bread recipe that calls for 4 eggs and 3 1/2 cups of flour. If she uses 7 eggs, how many cups of flour should she use? Express your answer as a mixed number. All right, so I've got a ratio here of 4 eggs for every, let's call that 7 halves of flour. All right, so that's my ratio. I'm going to use 7 eggs over here, and I want to know how many cups of flour that's going to be. So we got a proportion. 4 times x is 4x. 7 halves times 7 is 49 halves. And now I just divide both sides by 4, which is going to put that in the denominator down there. And I've got 49 over 8. See what I did there? When I divide by 4, I multiply by 1/4. So 49/8, but it wants our answer as a mixed number. So that's going to go in there 6 1/8 times. So our final answer is 6 1/8. We are moving now. All right, last two. What's the probability that a randomly chosen positive integer divisor of 32 is a perfect square? All right, so 32 is 2 to the 5th. So we should have 5 plus 1 divisors. There should be 6 divisors. Let's write them down. So we've got 1 and 32. We've got 2 and 16. We've got 4 and 9. No, 32. 4 and 8. Gosh. All right, so there's the 6 divisors. Which ones are perfect squares? Watch out. 1 is a perfect square. 4 is a perfect square. 16 is a perfect square. Out of the 6 divisors of 32, 3 of them are perfect squares. So half of the divisors are perfect squares. Watch out for crazy one there. All right, last one. Leona, just drop something. Leona has 12 coins totaling 85 cents. She only has dimes and nickels. How many dimes does she have? Okay, so she's got 12 coins. So her dimes plus her nickels is 12. The value of them is 85 cents. So 10 cents per dime plus 5 cents per nickel equals 85 cents. I want to know dimes, so let's get rid of nickels. How do we get rid of nickels? I multiply everything over here by -5. So -5 times d, -5d. -5 times n, -5n. My nickels are going to go away. -5 times 12, -60. I'm going to add the two equations together. I end up with 5d equals, these cancel, 85 minus 60 is 25. And I divide by 5, and the number of dimes is equal to 5. Final answer, and we are done, son. Nice job. Keep mathing hard. I will see you later. Bye-bye.